Welcome everyone. My name is Christopher Jones. I am a product manager in the data access team for Oracle Database. That means I'm a general technical go-to person. I liaise between Oracle's development groups, management, and with you as customers and users. So I get to do some fun things. I get to write some code, some documentation, some samples. I get to create and review functional specifications for great new features which are coming up that I can't talk about. I do a lot of other tasks to make life easier for you as consumers of our technology and for the Oracle developers who create it for you. And of course, I get to do demos like today's where we'll talk about Go and how to use that with Oracle Database. My colleague Sudarshan Sama is online to help answer questions. You might have seen his name and also that of Anthony Tuaninga on GitHub. They've both contributed a lot to this demo. So while we're all warming up, and getting up for some of you on the western part of Europe. I'm here in sunny Melbourne, Australia. It's a nice afternoon as spring comes along for us. It's looking like it's going to be a great season. So my wider database group, I just have one intro slide here, looks after all of the language APIs for accessing Oracle Database. And in particular, I am focused on the C-based stack, so using anything which is based on the Oracle call interface. I spent a number of years working solely with the PHP community, and then recently I've been working with Node.js, Python, and most recently with Go. And I should take a moment to thank all the community maintainers who do an excellent job out there with the database access APIs for Oracle Database. Later on, I'll explain why the community Go driver that you see on that slide has a hint of yellow there. So I just have a couple of introductory slides. I think Go might be new to a couple of you. So I just wanted to give a quick introduction and then we'll go straight into details of how to use it with Oracle Database. I won't go into a lot of deep architecture stuff with Go and confuse you early on. So it's a compiled general purpose language that grew from the history of things like C, rise of interpreted languages like Python. So with Python scripting languages, the development cycle is fast, but runtime tends to be a little slow, so you get that trade-off. And there's also less safety, if you want to call it that, with dynamically typed languages. If you look at languages like C++, then you find compilation time is slow. So Go attempts to solve some of these issues. It's gaining rapidly in popularity. In many surveys, it hovers around the top 10 mark. In this TOBE index, it's number 11, having risen a few places from 14 over the last year. Stack Overflow has it at number 12, and if you look at their most loved, it's actually at number 5 there. IEEE Spectrum survey has it at number 10. GitHub Octaverse survey is also at number 10. So it's certainly there to be a contender for you to use. Has good Oracle database support, great Oracle database support, and is widely used for a lot of systems programming, like it's used for the Docker container system, Kubernetes container management, all written in Go. And we're certainly seeing a significant number of downloads of the Go language itself on our Oracle Linux channels. So what Go has, fast compilation, obviously a feature, very fast. Simple cross compilation, I'll show that in a minute. Binaries can be standalone and have no dependencies, which is great. I have the asterisk there because that's only true if you're using a pure Go driver, pure Go application. Unfortunately, if you're using a C-Go program and we need that for Oracle drivers, then it's not quite true. We do have dependencies. I'll explain that later. Has all of those great things that you'd expect in modern languages, concurrency primitives, these things called Go routines. And the integration with C is where we hook in with the Oracle driver. So we had a little bit of discussion about what to call this slide. It's really what Go doesn't have, but it's really how it attempts to simplify things. So you'll see later on the error handling is just simple error checking rather than throwing exceptions. Uses structs instead of inheritance. Obviously, it's an expanding language. Things like generics are under consideration for future versions. Type system. This is the last of those intro slides. The type system, as you'd expect, some primitive types. Has things you might come across, runes, if you actually accidentally use single quotes and double quotes and you're used to coming from a scripting language, single quotes sort of have the C paradigm, meaning a single character, a rune, double quotes used to strings. Byte, we use a fair amount. You'll see that in some of the later demonstrations as well. The derived types, as you'd expect, based on the primitive types. Functions are first class, so you can pass them around. Maps are like Python dictionaries or JavaScript objects. Channels I'll go into, I've got some demos, so use those for the Go routines for concurrency. So I see a couple of questions coming up on chats or on Zoom. So if you have chat questions, please ask questions there. I see Rustam has put up a note, and Sudarshan will be able to answer things. And if he can't answer them, if they're not quite on topic, then we can get back to you later. So let me just go in and look at demo number 1. Okay, so let's go back to this. So on the right, I have a basic example of Go program for those who haven't seen it. Everything has a package. Oops, and where's my cursor gone? Still thinks it's in PowerPoint presentation mode. So package main, everything has a package, and the scope is, you can have multiple files in a package. Scope will be across all of those files for variables, etc. Typically, as I'll show you, just do a go run hello. I've given these numbers just so that I can keep track of them. We do them in the right way. This is a standard hello world. If you look a little bit lower, we're doing an import format. So that's trying to import another package from somebody else's space. That's a standard default package, as most of you might know if you've looked at Go. And scope lowercase is used for local variables. So this is not a global. And what else is there? There's not really a lot to say about this one. Let's have a look at, I think actually going to skip some of those others. Let's have a look at the channels, which is much more interesting. So if you look at the top again, we have the function main. So this is the entry point that the program will run from. Making a channel here. So this is like a pipe. You can use it for read or write. I will show you this with Oracle Database later, which is why I wanted to show you this one without it first. So make a channel, which is a pipe that people can write on or run from. These 3 lines here are going to be run in parallel. They're Go routines. So Go says, start this function, which you can see obviously below. Passing in the array, so that type definitions tend to come backwards if you want to call it that from a C standard. So this is an array of integers. You can obviously see the initialized values, and no surprises for guessing that this is going to do a sum of those values, and then it's going to pass that sum back down to the channel. This is a listener, so this is reading from the channel. It's going to get those values one at a time. The order may vary, so you can't actually predict what the order is going to be, and we'll just print out the values as they come. What else do we have here? Oh, type initialization. So this, for those who haven't seen it, you'll see this a lot in the other demos. This is type inheritance. So we don't need to give an explicit type for C. The compiler already knows what the type's going to be and can assign that directly. Variables get initialized to 0 if they're not initially initialized to anything else, which is kind of nice. So you get better memory management as well. Okay, that was the quick intro. Let me go back, if I can get my cursor back down to PowerPoint, and we will move on to the actual meat of the presentation, the database SQL package. So talk is obviously about accessing Oracle database. No surprise, we're going to look at the standard Go database/SQL package. It's a common database access layer. Generic layer has powerful capabilities. It's built in for all databases. Number of databases support the same API. So drivers for each database brand, for Oracle in our case, implement the interfaces in database/SQL/driver.
Chris, the presentation doesn't show the PPT.
Oh, sorry, thanks, Sudarshan. I have gone back. Okay, so there we go. Appreciate that. Okay, not that interesting, but it's good to have you there. So this generic layer provides useful support. It has support for the Go routines, as we just saw. It has some connection pooling. I'll get into that a lot later. Has a little bit of statement caching. and context. So if you want to time out or break a statement, similar to a break reset you might have seen in other Oracle land, you can use context here in the Go driver. Okay, let's move on. So database type support, again, it's generic, so it has to be sort of lowest common denominator in many senses. It deals with simple types. For nulls, it has some specific types. So there are a couple up there. There are more for things like the 32 bits as well. One thing that the Go driver for Oracle doesn't have is it doesn't actually support the SQL null string. In Oracle land, Oracle's one of the first relational databases that actually defined null and empty strings to be the same. Standards came along later, but we already had such a big customer base that we really can't break something like that. So you're going to end up with empty strings there for nulls. The driver that I'm going to show, the Go driver, as you would have seen on that block diagram earlier, another thing to note is it actually fetches numbers from Oracle database as strings, so it transfers them across the wire as strings. And that's because Oracle database number format is in decimal encoding. And obviously in languages, they tend to be in binary format, and that decimal to binary conversion sometimes tricks unwary people and you end up with numbers which don't quite match. My general recommendation for numbers, especially if you're doing financial calculations, is to use SQL and PL/SQL to do financial calculations because of the decimal format benefits there, rather than trying to do all sorts of rounding issues in a binary format in a language. Having said that, I know a lot of you still use the languages to do number formats, but number calculations, but please be aware of the issues there. So there are a couple of drivers out there. These are the two active ones at the moment. The top one I'm going to speak about, the Go driver for Oracle. It's currently maintained by Tomasz. Well, he created it and he maintains it, Tomasz Galaxy. It grew out of something which was called the Rana Oracle driver. Tomasz was ending up to be the sole maintainer of that. He saw that we were starting to build database access drivers on top of that ODPI-C layer I showed in that block diagram, and he wanted to rewrite something, so he started his G-Oracle driver. It got renamed at some stage as we began contributing to this Go driver for Oracle. The other contender out there is the Go OCI 8 driver, and I really should thank the kind of hidden Matt N, anonymous Matt N, and the Michael S11 who are maintaining that now on GitHub and doing a lot of good work there. But that uses direct Oracle call interface calls, whereas we have the extra interface layer, the ODPI-C layer in between. So just a little sidebar about that ODPI-C layer. Historically, many languages, APIs, PHP, for example, use those direct OCI calls. That Matt N driver, the Go OCI 8 driver, use those calls directly. That means they have to do a lot of their own memory management. They have to take into account a lot of portability quirks here and there, version quirks. They have to do things with pooling to make that handled well. So we introduced ODPI-C to smooth out that layer. It does memory management, does reference counting, exposes native types. It's now being picked up by a lot of the new drivers. As you can see there, the Erlang driver recently got rewritten. Rust, the Ruby maintainer, started the Rust driver. We have Julia and Nim drivers, et cetera, et cetera. You can also use it for any C program or C++ program. But it does make life a lot easier. It makes the Go layer a lot thinner. Okay, so what does this really look like now? We get this multiple stack view. The Oracle call interface and the Oracle call libraries, that's a shared library, so that has to be loaded separately. So therefore Go, and we don't yet know how we're going to pronounce this, Go draw, the Go driver for Oracle has to use CGO, so it has to interface with the C API. But that call interface does give a lot of functionality. The Oracle client libraries give you a lot of performance, compression, high availability features, failovers, pinging, load balancing, event handling. So all of that is just inbuilt into that thick client stack library. It does things like statement caching, and the Go draw driver uses 40 if you're using connection pooling. So there's a statement caching so that the text of statements doesn't have to be sent across to the database every time you re-execute it, and the metadata doesn't have to come back. Big benefits there in terms of scalability. Oracle Net itself, so Oracle Net's not another product, it's just the communication protocol between the database and that client stack. Provides a lot of the connectivity and the failover, encryption. So often people come to us and say, well, I can't see it in your Python driver, in your Go driver. How do I turn on encryption? Well, the answer is you don't turn it on in the driver, you turn it on in the Oracle Net layer underneath, so the documentation is somewhere else. Oracle has standard client-server version interoperability, and that means that any particular call interface library, the client libraries, can talk to different database versions. For example, if you have Oracle Client 19C, you can connect to Oracle 11.2 database, 12, 18, 19 databases. So you don't need to stay at an old stack if you want to get the latest and greatest features in that Oracle Client library. Okay, let's have a look at another demo. And let's see what we got in our 02 list. Oh, so these are just the basic connections. So to install the driver, you do a standard go get. And obviously you need to know where to get it from. I have already done that, so I won't need to do that now. As you saw in the stack, you also need the Oracle Client libraries. So on Mac OS, that stack is available, and Windows and Linux and all the other platforms. You can do a straight curl or a wget to just download the latest zip file, or you can go to our download pages to look at particular versions, or if you're on Linux, they're the Yum channels, so they're available in a number of places. At the moment, this is pretty easy. You can just CD unzip to your location. Unfortunately, this is slightly older, so it wasn't notarized for the latest versions of Mac. This is Mac specific, no issues there on Windows or Linux or other platforms, but Apple's been clamping down on third-party libraries. The next version will be notarized, but for the moment you have to go and authorize in the security preference page or just run an xadder command. So I've unzipped them. As you can see lower down, we tell the Go driver where I've actually unzipped them to, so I don't need to go and fiddle with any library path settings, anything like that. And this works on Mac OS and Windows. Sorry, it doesn't work on Linux. You still need external LD library path or LD config on Linux. That is explained in the install instructions, both for Instant Client and the drivers. So what have we got? Obviously, we need to have database SQL package. We need to include the Go driver. We're not going to reference it by name, so we just have this underscore. For those who are not familiar with that, that basically means ignore a value, and you often see an underscore in simple code where you want to ignore part of a return value. Tamash recently introduced this log formatted connection string, the data source name, and this is the kind of modern preferred method of connecting. You might see some other formats out there, and those are documented. Username, password, fairly standard. If you don't like putting a password here, you can use what we call external authentication to use a wallet or Kerberos or something like that. Connect string, this is the Easy Connect format. A lot of people are familiar with that now. So it's the host name where the database is running and the database service name that's running there. Then we register with the database SQL package. And this actually doesn't do anything other than just sort of register this DSN. It doesn't actually open anything or start anything. So this is not a particularly useful example. It does show the error handling though, that we do explicit error checking, and I'm just going to throw a panic here and not do anything fancy. Defer is quite nice if you're not familiar with Go. It basically says that any exit point from this main routine, if I was returning early, breaking out somehow, then the database will always be closed, and I don't have to have multiple close to call through every single exit point. Let's have a look at the next demo, which is, and I'll run this. So this is slightly more advanced. We've seen these before. What this does have here is if you have Oracle 19C, you can add extra options onto that Easy Connect syntax. And that means you don't need configuration files to do a bunch of things which you would need in earlier versions. These two options I'm showing here, this is a TCP keep alive. For example, we found on Azure that the firewall was being killed every 4 minutes, so we set the expire time to 2, so about half the kill time. That just keeps that network connection alive, so the connections don't drop out if they're not being used for a little time. Connect timeout, if there's a network issue actually creating a connection, want to get a response back in a couple of seconds. So we don't want to hang there for some time. So similar to before, the open doesn't do a whole lot, but when we come to a ping, or as we'll see later, things like the exec, when we actually run statements, that's when the connection is open. So the connection is opened, it's used, and released, all in the one time. And then we can run, and the database pinged okay. No, not a problem, which is good. My database is running, which is always helpful for demonstrations. Let's go back to presentation land. So that data source name, as I showed you, has a bunch of options. These are some of them. There's some other ones for pooling, which we'll talk about in a bit. I won't go through these all, but you can see that we have things like if you want privileged connections, DBA connections, if you want some of those events I mentioned, if you're doing query change notification, or you want those fan events for fast application notification events for some of that high availability features, you can enable those. Tamash has a couple of other things available. I'll speak about config later. So connection pooling. Why do you want to use connection pooling? So what is a connection pool? It's a pool of connections. Surprise, surprise. And more importantly, the connections are open, they're established, and they just remain open all the time, which is why you don't want things like firewalls to be killing them, because opening connections is expensive. You have to start up a server process in the back end, you have to allocate some memory, you have to, network listener has to wake up, et cetera, et cetera. So you want these connections to be open all the time. So pretty much every serious app would use a connection pool when it can cope with memory. We do have other kinds of pool I'm not going to talk about too much today. You might see DRCP, database resident connection pooling, go up if you have in slides, and you would use that if you have a very, very, very large number of connections. But for most people, you just use a connection pool in the application. So here, obviously, we have our 3 users using 3 connections, and then the 4th connection is just waiting for some user to come along. It's important for scalability and performance to be using a connection pool. So connection pooling, there are actually 2 connection pools in this land, in the Go driver for Oracle, and they're both enabled at the same time, which is slightly confusing, and I recommend you not use the default. So the first connection pool is a sort of simple one at the database/SQL level. It has a few tuning options. I'll just show you those in a slide or two. It's kind of, we'd call it the fastest because it doesn't have to go through the stack to get the connections, but it does sacrifice a lot of the high availability things that Oracle's own connection pool can use. If your SQL is slow, you probably won't even notice that it's a little bit slower just to get that connection in the first place. Then Oracle has its own session pool. That's called session because the word connection was used for some previous incarnation, an older version. Nowadays, everybody uses the session pool. It has the best support for those high availability features. And as I mentioned, that other kind of connection pooling, I won't go into the DRCP, the database side connection pooling for high-end users. Those 2, just for the slides, then we have the various settings to enable those, and I will talk about that at the moment. The default max idle cons is 2. So effectively, if you just want to use database SQL connection pooling, you have to set the standalone connection to 1. And as you can guess, you can disable all the connection pooling by setting standalone connections to 0. Sorry, to 1. It does get very confusing, and we've tried to simplify it and just distinguish it. And I'll give you some examples. I won't read all the slide, but you can see these are the 4 major options here for the database/SQL connection pool. They all set with this DB function call. So you actually have to create the DB connection first, and then you get fairly standard how many connections do you want to have open, and then how many you want to have idle. If they're not being used, you want to kill them off immediately. I'll talk more about that in a minute when I show you the demonstration. At the session pool, if you're using Oracle session pooling, you get a lot of benefits. You get things like socket checks to make sure connections are still valid if they haven't been used for a while, automatic connection reestablishment, HA features that I mentioned before. So my personal preference would be to use this, but just benchmark and check what your feature requirements are. Again, a whole bunch of parameters here. These two slides that I'm showing you will eventually make their way back into the Go Oracle driver doc. So we have been starting to contribute there, done a little bit of work with the doc, haven't had a lot of time. And so when I get a moment, some of this will go back and it'll just be a little easier to access for you. So let's have a look at demo 3. So this is the session pooling. 03, how am I going for time? Pretty good. So I'm just going to show you these two pools. So this is the first pool, no surprises here. One little trick is that just in case I had to swap databases, I'm now reading my connect string from an environment variable. So I'm now setting the parameters, some of the parameters which are available, not all of them. So min are going to start with 4 sessions, never going to get more than 4 sessions. And obviously, since we're not going anywhere, we don't need any increment, set that to 0. The important thing here is that we set the max idle cons with the DB structure. So we say we don't want to use database SQL connection pooling. If I run this, you'll see that it doesn't do very much, but the database ping now will get a connection from the pool. So there'll be 3 in the pool, 1 in use. It will use that and then return it back to the pool for some other part of the application to use. Obviously, if you're running it concurrently, then other people would be trying to use the pool at the same time. What else is there to say about this? Not a lot. I mean, you can see it in action if you want to, if my fingers will warm up. And it takes a little bit more time to start because you have to create those 4 connections at one time. The point about having 4 connections for max and min is that's a static size connection pool. And our real world performance team likes static connection pools because just in that morning when everybody wakes up and starts hitting the database is just when you want the database to do work. And so you're just really slamming, you're getting a connection storm on the database. So they don't want connections pools to be growing and shrinking because that causes a lot of memory allocations. I mentioned connections are expensive to create. They like pools to be available all the time, no firewalls killing them, no DBAs, expiring idle sessions, resource limits at the database side, and then keep your min and max as the same. Obviously, you may have reasons for not having them the same, but this would be my general recommendation. And if connection isn't available, if 4 other people were already pinging and the 5th person came along, this ping will wait for a connection to become available. So the other example is just the Go pool, similar sort of thing, but in this case we set these 2 things. Actually, you only need to set one of them, but the discussion here again is centered around, do you want these connections when they're not being used to be killed or not? So would you keep them the same? And you might have reasons for not keeping them the same. Oh, and sorry, it's standalone connections. So standalone connections is the way to say we want to use the session pool. Sorry, the database SQL pool. So back to slides land. So it is a bit of a connection parameter soup. As you saw, this was the Oracle example. So what do we have? We obviously have our sort of stack, which we've seen before. So up the top, we have database credentials, and these obviously go through the database. And I mentioned you can use external authentication if you don't want passwords to be shown. We have Oracle Net parameters. So anything which is Oracle Net related, that security, that encryption, the timeouts, keeping networks alive, wallets for authentication and security, you would be specifying at the Oracle Net level. MDT is actually my desktop. It's the name of my desktop machine, and service name you've seen before. Pooling parameters, if you happen to be using OCI pooling and have a number of connections down to the database. And then libdir I've mentioned, where Coda finds the Oracle client libraries. And finally, of course, we want to stop database SQL doing its own pooling in this particular example where we just want to use Oracle session pool. So that's, in my mind, a sort of critical slide. I'm not sure it actually makes it any easier to understand, but if you are kind of confused about things, this is perhaps a good slide to refer to. So all those previous examples used that EasyConnect syntax. If you're not using EasyConnect, you can use our traditional network configuration files. And here we're specifying that connect string as the MySales connect alias, and that's specified in a MySales, in a TNS names.ora with a MySales and a descriptor giving the same information, the host name and the ports and the service names to connect to. You can add a lot of extra options here, most of which you can now push back into that EasyConnect syntax. But you may find it easier just to use a TNS names.ora, keep your applications clean, and then you can just change the configuration files as you need to. One extra option here was the config.dir. So this is the location with all of these network configuration files. So you no longer need to set the TNS admin. Some of you Oracle people know TNS admin environment variable. In fact, this will overwrite any TNS admin you've set because it actually internally sets TNS admin, if that makes sense. So hopefully we're just trying to make things easier so you can package things up. Just a couple more slides before I go into a bunch more demos. So if you're not using that EasyConnect syntax, then we do have all of these options that you can see on the screen for things like the expire time. We've seen that with EasyConnect. So you want to send probes. If you want database itself to wake up and kill things, if database connectivity across that network is slow, you can set these receive timeouts and send timeouts. TCP timeouts for connections if, again, you want to bound the connection time. So here's just one quick example. So retry count, retry delay. Could have done this with the EasyConnect syntax, but here I can do it explicitly in the TNS names file. So if the network has dropped out, glitched for a minute, you may not want your application to return an error. You may want to just wait a little bit. And here, actually going to wait some time. We're going to keep trying to reconnect to that database 10 times. If there's a failure, I'm going to wait 5 seconds or so. The other little interesting bullet point down there, that the big speech balloon, is that when you're connecting to these things, we generally recommend creating your own service, not using the default service. And that's because the Oracle features for high availability, such as our application continuity and transparent application continuity, fan events, they're all configured on a service at the database side. So you configure that on the service and you want your application to be using that service. It just makes it easier. Okay, let's look at the next set of demos. Actually look at some bits and pieces in here. What have we got? We've got LS04, 05, got a few to get through, 04.1. So what's magic in here? So this is actually doing a query. We've got our standard open, deferred, close, query statement, SQL statement, again, using the type inheritance. We know it's a string. Back quotes are really handy for multi-line strings and those with embedded quotes, as you would have seen up the top. And here we're using the database query row method, passing in the SQL syntax, and this is the bind variable parameter. So we're using bind by position. It's just a random number. It's the first bind variable, which will map into this ID. Must use bind variables with Oracle for performance, for security, scalability. Really do use them in SQL statements. One little extra thing here is that we're setting this thing called fetch array size. I'll go into this more, but it's an internal tuning parameter. We're only fetching one row, so we may as well just set that size to 1. Scan is kind of fun. It says, hey, on that row that got returned, give me the one column. I know there's one column because my query had one column. Give me the data into last name, and obviously with the line above, we know it's going to be a string. 041, and there we get the query. So employee 100 is, last name was King. Let's have a look at the other case, as you would have read ahead, multi-row query. So I've got a query down here, pretend that it's fetching a large number of rows here. Obviously it's not, it's just fetching from this sample Oracle table, which is available on GitHub if you want to install the sample schema. But pretend you don't really know how many rows, maybe hundreds, maybe thousands. Here, when you do the query, so we use the query method in this case, query function, we set these prefetch count and fetch array size. So these are internal tuning parameters. They vary about where they apply to in the stack. Prefetch count is traditionally when you send a statement across to be executed, you get back a success or failure message. Prefetch is sort of saying, well, give me data back. I know I'm going to fetch data, so give me some data back anyway. So this is going to give up to 1,000 rows back at that time. And then if you have lots and lots of data, you have 4,000 rows, you have to go back to the database to get more rows, then the fetch array size plays a part as well. So if you're fetching really, really large numbers of rows, you'd probably set these two to be the same value. Some rare cases, you might even set prefetch count. So just not set it, just let it default. There are some extra buffer copies across memory. So basically do your tuning based on these two things and do your tuning in production where the network speed is known. I think you would have read ahead, we're creating a couple of variables to alter two columns, and you can kind of see as we loop across every row. So we're just looping row by row. So we're scanning, so we're just getting those two columns back and printing them out. Rows.next will return nil on error or end of fetch. So we actually have to check, was it an explicit error itself? Go run 042, whoops, 2, no surprises, multi-row queries. So let's, as time is winding down, let's just jump ahead. So I won't run some of these. This is what we call a page query. So we're using Oracle's standard syntax for, since 12.1, we've had this offset fetch next syntax, or you can work around it in earlier versions with row num. And the key thing here is that we're setting the prefetch counts to the number of rows you're fetching plus 1, and then array size just to the number of rows you're going to fetch. So these are going to be bind variables bound in with a colon syntax. And so here are the two data values coming in from the application into the SQL statement. And the reason for that +1 is to avoid an extra round trip at end of fetch. So if you know you're only going to fetch 10 rows, basically you need to sort of fetch 11 so the buffering works correctly in the lower layers. Again, these are internal tuning parameters, don't affect how many rows actually get returned to the application or when they get returned. No magic there. Let's have a look at 5 DML. So how do you actually insert data? So I've got a little bit of a code here, which does drop and create. And there are 2 bugs in this, and I want to point them out. One is there's no error handling, so that's bad. So you should always have error handling. And the other is this is 2 exec statements, which is 2 round trips to the database. And I really should be using a PL SQL block, begin and end, and putting both of these statements inside that PL SQL block. So then I can just call exec once. So that's 2 bad things. But just to insert DML, this is what we call array DML, array binding, bulk DML. We're creating, in this case, 10 rows. We're creating data values, creating arrays in string states, and just populating them with some data. No magic here for those who haven't seen it. Range is just going across the keys, the 0 onwards for the array. In this case, obviously the arrays are the same size. This exec we've kind of seen before. I didn't mention it with the other queries, but again, this gets a connection from the pool if one's available, does the insert, auto commits, and then pushes the connection back to the pool. So what this is this is one exec inserting 10 rows. So this is much more efficient than trying to have a loop around exec and calling exec 10 times. No magic here. When this runs, you're going to get some data back, all of the data which gets inserted in my Australian Eastern Standard Time. Time here on the way back tends to be date, so time.time, so you tend to get loss of fractional seconds. If you're using timestamps, you may want to be using strings, and Tomasz has some notes on that in the documentation. Okay, I've got one more slide, I think, and then you can see we will be going back. So round trips, I kind of mentioned. Scalability killing, you really want to reduce round trips. We saw that with query, with the prefetch size and the array size to try and reduce the round trips just to get data. Obviously, you have to tune your SQL and tune your application and even tune the network packet sizes as well. But from the driver point of view, specifically, you want to reduce the round trips. So this diagram is inserts, so that bulk insert versus say a loop of inserts. And you can see that even for small values, you actually can't see here, but even for small values, you'll see it much more efficient to use that bulk method that I showed you rather than a loop. I'm calling it exec multiple times. So if you're doing data loading, certainly use bulk operations where possible. So that's it in terms of slides, which is good. So let's just run straight through the rest of the demos. Oops, sorry about that. And we can have a look at these other demos down here. So DML returning is an example where I'm going to show you the out binds and named binds. So I showed you, insert, I showed you binds before. This one now has a returning clause. So this is where you could get a key out from a database if you want to get the identifier for a newly inserted row. In this case, I'm just getting the timestamp out, the date out. Sysdate is going to come back in this bind variable. So different to the previous examples, named bind variables has some benefits, especially if you have reused names more than once in the SQL statement. I think you can see that KBV maps to this position up here. So I'm going to pass in 100 and Petra, and here I'm getting out. So this is saying pass a bind variable out, and obviously destination is saying pass it into this inserted variable created up just above. Time was inserted. I'm a bit cognizant of time as we're also running out of time for the session, but you can see that the time gets inserted, the row gets inserted, which includes the time, and the time then gets returned back to the application. As I say, perhaps more useful for getting the keys back for newly inserted rows. Okay, concurrent DML. So this is where the channels come in and the pooling plays a part. So just skipping over some of those lower level things. Here we have channels, and you saw the channel earlier. You might use this if you want to really parallelize a data load. My data load is just inserting one row, so it's not really particularly stressing on anything. But effectively, we can insert batches of records, and that might be useful in some situations for you. Now, each of these is going to use one connection from the connection pool, so you'll actually be putting more load on the database. But if that's the way your application works, that's what you need, and you need to work with your DBAs to make sure you have enough connections available on the database side or even in the application side. What have we got here? The couple of things I haven't really mentioned, I guess, error, underscore possibly mentioned, is when you wanted more value. We don't really care what exec returns. We just care, did it fail or pass? So ignore that. The channel, we also don't actually need the value. We're just passing back any value. So we're just passing back one. And again, we don't care about what the channel is. So we're just ignoring where that gets assigned to. And once all of these are done, they're going to operate in parallel. We get 5 Go routines operating in parallel. Then we can query the database, and job is done. So I don't know what you would like me to look at in the last few minutes. Transactions are handled by this begin syntax, and then you can either do a commit or a rollback. So anything in between will obviously be part of that transaction and not be committed or rolled back until the end. Quite often you might defer a commit, so you'd have a defer statement after the begin. So the begin is going to get a connection and hold it open until the commit occurs. I don't think I need to run that. Lobs are quite useful in the last minute or two. So there are 2 methods, and Tomasz has actually changed from one to the other. In recent versions, he's changed to the fast version, which is simple. And this just deals with strings and bytes. Works for lobs up to about 1 gigabyte, which is probably more than you want in memory at any time. So we just bind these things, obviously create a byte array, string array, binding these in as you would have seen before into the SQL statement, which you can see up above. And then query comes back again, just a straight bytes, and we just scan them back as string or byte. So that's really, really fast. The alternative is this whole reader interface, which you would only use if you're streaming videos and things like that. So I know it's right at the end. I don't know if people are running off. but I do have some more demos. We hope to get the demos up, recording up at some stage. You'll see some information about that, or just follow me on the blogs. And I can just continue running on until moderators jump in and stop me. PL SQL functions, no surprises. Again, you're just binding. So it's just all about binding data in or out. In this case, we're going to bind the result. It's out, it's a positional bind. So the first position in the exec maps to the :1. So that's the out bind, obviously. We need to get data back. In-out bind, so you specify them as out, and then also you specify them in as well. So it's going to be an in-out bind, as you can see up above in the PL SQL code. Bind in-out varchar. When you run this yourself, you'll see how it works. Ref cursors, a lot of fun. Effectively, again, this is a PL SQL procedure which has an out bind, just passing out the ref cursor, which is the query result set for this query. And then in here, we obviously have to get the row. So we passing, sorry, where's the wrapping the row? We're getting the bind variable back. So we have a ref cursor, which we got back, again to further close on that. We wrap it to give back a SQL.rows object, which we then can just iterate over as we've seen before for all of the other queries, just scanning for the columns that we're expecting back. And yes, there are ways to introspect these things and find column names or whatever if you don't actually know what's coming back. Let me just pause there and look at the chat and see what people are asking. So we will certainly be looking at getting presentation up, and hopefully you'll see things this on live as well at some stage, or replay at some stage. Nested cursor is very similar to PL ref cursors. AQ is a bit of fun. Let me just finish up. I'll do 2 more minutes. Advanced queuing, very fully featured queuing system in Oracle database. One key thing about it is that you can do what they call transactional consistency. So this code down here, visible on commit. When you send commit, you can, at the same time you commit data to database, you can also send a message. So obviously if you roll back, none of those will happen. So you're not going to send messages without data being in the database, or vice versa. That's a major feature that we have here by doing it inside Oracle database. The top stuff in green, you can see just creates queues. Yes, we use PL SQL for that. Grant stuff because we're doing it all as a hacky development user. So we spoke about visibility, delivery modes. So one of the options about whether or not it's persistent in the database, or if the database goes down, whether they get lost. Got a couple of routines for putting messages and reading messages. Oops, sorry about that. Stop that. Just going to pass some text here. This is a raw queue. You can also pass objects. Fully featured, so you can say expire messages if they're not being haven't been read for a while. They can just disappear from the queue. In this case, 10 seconds. We're just passing strings, so we're just using this bytes and queuing messages. I'll just run this as I talk. And then the dequeue is very similar. This is called array dequeuing. So we're going to accept only 2 messages back. And the various options like don't wait for messages if there's nothing in the queue, or wait, or take messages from the queue, but also leave them in for somebody else. So it's quite a fully featured system. On the left, you can see there's some of these other options which I haven't talked about: exception queues, IDs, delays and expiration, priorities, and all sorts of things. And at the bottom, I just printed out the actual text of the message. So I've dequeued a couple of messages. User-defined types, quite commonly used in the spatial data world, because we have those predefined spatial data objects in all editions of Oracle database. Here I've created a little type myself, book type, table with this type. And then we have this new object, get object type. Now, one note here, just want to finish up with get object types. It's very slow, so don't do this more than you need to. In fact, Oracle objects tend to be relatively slow, so do as much of this in PL SQL as you can. And then you just set the attributes. These are the title. You can see title, author, price, map straight up to the fields of this object. And again, on the way out, exactly the same object get to get data out. So I have some examples there. Oops, I knew I was going to do that somewhere. So used to other languages. we get data back out again just from the format print at the bottom. So that's it from me. We have resources up there. We're going to put some more effort into this driver. Unfortunately, we had a testing team changeover, so we're a little bit behind on getting some of the testing, new tests updated there. And I'd like to get a lot more of the doc out there. So if there are any questions, I can take questions. I don't know if Rustam, if you want to read them out, questions. As I said, we'll get this presentation out to you and certainly the code examples. So I can see Rustam's chatting to me. I can't see any questions. So Rustam, I don't know where we are. Oh yes, we're in the Q&A. I know, yes.
Someone asked the question. Could you answer, please?
Question about using it in production applications. We have customers using it in production applications already. So Tamash is very active, so he's changing things left, right, and center. Certainly, like with any of the open source projects, keep track of it and do your own test suite. But certainly, we do have customers definitely using it in places like banks and things like that.
One more question.
And that's it. And there are ways to close connections within connection pool. I don't think Tamash has actually got the drop connection sorted out because you know, through the abstraction layer of the database SQL that he has to work, a lot of that stuff isn't available. But certainly you've got the expire times and things like that if you want to. There are features there in that big slide I put up with all the features. You can expire connections which haven't been used for a while, so they disappear from the connection pool. So that was the question. I think I've answered a couple of questions, and I'm going to mark those done.
Yeah.
And if we're good, then we can finish up and just thank everyone. Thanks, Sudashan, for being around. Thanks, Anthony, for writing a presentation. Thank you very much, everyone. Goodbye.